This is question 2 on the June 2013 Q2 paper for S1. So we've got a normal distribution question here. The weight x of the contents of a tin of baked beans can be modelled by a normal random variable, and I've got a mean of 421, standard deviation of 2.5. So I'm going to write that as x is distributed normally, mean 421, and then standard deviation. So I always put my variance in there, so standard deviation squared. So the first part, I need to find the probability x is equal to this value 421. So the normal distribution is a continuous distribution. So that means that the probability of being any particular one value is so small that we can say it's equal to 0. So the probability that x is equal to the exact value of 421 is equal to 0. Part 2, the probability x is less than 425. So I need to use my z distribution here. So that's going to be the probability that z is less than 425, take away the mean 421, divided by the standard deviation, which is 2.5. So if I work that out, that means I need the probability z is less than 1.6. That's my z value. And I can use my calculator to work out what that probability is. So I'm going to go to the stats menu, shift, just like that, shift 1, and distribution, we're looking at the normal distribution, and I want the probability being less than a certain value, and that value is 1.6. So that probability is 0.9452. 0.9452. Part 3, I want the probability being between two values. So what's the probability x is between 418 and 424? So I'm going to draw a little normal distribution down here. I'm going to imagine that's symmetrical. So I've got 418 here, and I've got 424 there. And if we think about it, we've got our mean in the middle here at 421. We can see actually these 2 points are both 3 away from the mean. So it's symmetrical. I want to know what's the probability of being between those 2 values. So this blue shaded area here. When I look up my values on my table, I can look up everything less than a certain value. So I'm going to convert these to z's in a moment. So if I look up the probability of x is less than 424, that'll give me everything there that I've shaded green. But I don't want this bit here. I don't want the bit that's less than 418, because that's outside my area of interest. So I need to take away the probability of x being less than 418. So this is where a lot of people make a mistake. They think that they need the bit in between, so they're changing the sign to x is greater than 418, but that's not how we're working it out. Okay. So let's work out the corresponding z value. So we know it's going to be plus or minus. So if I think about my z distribution, the mean's always 0. These 2 z values are going to be the same, but one's going to be the negative version. So for 424, we can look at the probability z is less than. So I've already said the difference is 3, and my standard deviation is 2.5. So I need the probability z is less than 3 over 2.5, which is 1.2. So that's the z value I need to look up. So I can do that on my table, or I can do it on the calculator like we just did. So we use shift and stats menu, number 1, distribution, probability being less than 1.2. 0.88493. So that's my probability being less than A. I want to take off the probability of being less than minus 8. this bit here. So this bit here, the probability of being less than minus A is the same as the probability of being greater than A, because the normal distribution is symmetrical. So these two shaded areas here are the same probability. So I need to take away from the value I've got I need to take away 1 minus that value, because that's how I work out that red shaded bit there. So it's a bit counterintuitive, but as long as you're drawing a diagram, it should make sense. So I'm going to work that one out, and what do I get? I get 0.7. 6986. Okay. So that's my answer there. It hasn't told me what kind of accuracy it wants in the answers. So because I've worked it out, I could leave it like that. However, if we go back to the instructions that it gives at the start of the paper, it says we should normally give our final answers to 3 significant figures. So I might want to round that one to 770. Okay? So I always need to make sure I'm doing what the question is asking me there. Moving on to part B then, it says determine the value of x such that the probability of being less than that value is 0.98. So I need to use my reverse normal table to do this. So I'm given the probability, so this is the percentage points of the normal distribution. I'm given the probability of 0.98. So if I think about what this is going to look like, got my normal distribution, I want the probability of being less than a certain value to be 0.98. Okay? So if I want to see what z value goes with this x value here, I need to look up 0.98 in this reverse table. And there I can see that the corresponding z value that goes with it, z, so this is part B, is equal to 2.0537. Okay? So I'll just move that one out of the way. So I'll put that one there. So I've got my z value. I want the probability then x is less than, what z we're on now, aren't we? Z is less than 2.0537 is equal to 0.98. So I need to work out what x value would give me this z. So I don't know what x is, but if I take away the mean, which is 421, and I divide by the standard deviation, I will end up getting this value of z that I've just looked up, which was 2.0537. So all I need to do now is a bit of algebra. So x minus 421 equals 2.0537 times by 2.5. So that means that x is equal to 421 add on to 2.0537 times 2.5. So x is equal to my value 426.13. So that's part B. And part C, so just tidied the screen up a little bit. So part C, the weight y grams of the contents of a tin of ravioli can be modelled by a normal random variable as y is distributed normally with a mean of mu and a standard deviation of 3, so the variance is 3 squared. This time we need to find the value of mu, so we don't know what the mean is of the population. But we do know that the probability of y being less than 410 is equal to 0.01. So if I did a nice sort of sketch of that one, I want it to be less than a certain value, 410, is equal to 0.01. So I know it's going to be over here, because I know that 50% of the data is less than the mean. So that means that 0.01 must be that. So I need to work out a z value that goes with this again. So obviously I know that if I'm thinking of my z distribution, the mean is 0. If I'm to the left of the mean, I've got to be a negative z value. I'm going to use my reverse normal table again, but I can't look up 0.01 on that table, because it's not an option. It only goes from 0.5 to 0.99. If we have a look down here, these are the probabilities that I can look up on my table. So what I'm going to do is I'm going to think about, if I look up the value for 0.99, then this shaded value that I've got up here, the probability of that would be 0.01. So if I look up the z value for 0.99, so before we use that one, so this time it's going to be this one here, 2.3263. So we've already just said that I want the negative version of this one, because I actually want this value here. So the z value that I've got, probability of the z, is less than minus 2.3263. Is equal to 0.01. So I've just rewritten the question using my z distribution there. So now, like we did in part B, we can solve that. So we don't know the mean, but this time we do know the z value. So minus 2.3263 is equal to the x value that we've got, so that's this one here, or the y value, now we're dealing with y, 410, minus the mean that we want to find out, divided by our standard deviation, which was 3. So I'm just going to solve this like I did before. So this time I've got minus 2.3263 multiplied by 3 on the left-hand side equals 410 minus mu on the right-hand side. Now, some people think they can just take off 410 from both sides and that would give them the same answer. So we just need to be careful when we're rearranging. So that would actually give me mu. So if I add mu to the left-hand side and take the rest to the right-hand side, equals 410. So I want to take away minus, well, I need to add that on, wouldn't I? I need to add on the 2.3263 times 3. And I know that I should be adding there because I want the mean to be bigger than that value of 410. So if I had some takeaway here, then I know I've done something wrong. That has to be an add. So if I calculate that, then I should get that mu is 416.98. And then again, I need to round that to 3 significant figures, so that'd be 417 to 3 sig fig.